About 4.6 billion years ago, the sun did not exist. Our neighborhood was part of a cold molecular cloud filled with hydrogen, helium, dust, and older star material. A disturbance made one dense region unstable. It may have been a nearby stellar shock, but the exact trigger is uncertain. Once collapse began, gravity pulled more material inward. The cloud was already rotating a little. As it shrank, it spun faster and flattened into a broad protoplanetary disk, much like a skater spinning faster by pulling in their arms. Most of the collapsing mass fell toward the center. The growing protosun became hotter and denser while fresh gas and dust continued spiraling inward through the disk. When the center became hot enough, hydrogen fusion began. The newborn sun released energy and strong winds, becoming the star that still powers the solar system today. Inside the disk, microscopic dust grains collided and sometimes stuck through electric forces. Over time, grains became clumps, clumps became pebbles, and pebbles became larger bodies. Gravity became important once objects reached large sizes. Repeated collisions built kilometer-wide planetesimals, then moon-sized embryos, and finally the major planets. Close to the young sun, temperatures were too high for most ices. Rock and metal dominated, producing the ingredients for Mercury, Venus, Earth, and Mars. Farther out, beyond the snow line, water and other compounds could freeze. Large icy cores formed quickly and captured hydrogen and helium, creating the giant planets. Computer models suggest Jupiter and Saturn may have shifted their orbits. Their gravity scattered smaller bodies, rearranged debris, and helped shape the architecture we see today. Not everything became a planet. Leftover rocky objects remained in the asteroid belt, while icy bodies survived farther away as comets and distant Kuiper belt objects. Early Earth probably suffered a giant collision with a Mars-sized body often called Theia. Debris from that impact gathered in orbit and eventually formed the Moon. Earth's water likely came from several sources, including material already present during formation and later impacts from water-rich asteroids. Carbon-rich material also delivered useful chemistry. As the sun brightened, radiation and solar wind removed much of the remaining gas. Collisions slowed, most debris was cleared, and the planets settled into more stable orbits. Scientists reconstruct this history using meteorites, crater records, computer models, and young star systems seen through telescopes. The oldest meteorites date the solar system to about 4.6 billion years.